So, second video on redox reactions. This time we're going to look at half equations. Before we start, please like, subscribe, share. Let's keep growing the channel. Let's get into it. So, half equations are equations that are essentially showing us the movements of electrons. So what's happening is something inside these half equations is changing oxidation number, and again it's because of that movement of electrons. When we combine these half equations, they're going to combine in such a way that these electrons cancel out, but that's the focus of the video next time. Easiest thing for us to do is to get into some examples. So we've got these 5 steps, and we take each of these 5 steps in turn. So first of all, balance the atom that's changing first. And by changing, I mean changing oxidation number. Generally speaking, we're looking for something here other than oxygen or hydrogen. So we can see here we've got V2. We've only got one V on the left-hand side, so we need 2 to balance that out. Step 2, balance the O's with H2O. Worth noting here that all of the time these things are going to be aqueous. And what that means is when something's dissolved in water, we've clearly got an excess of H2O, and that H2O has this equilibrium where we can get H plus ions and OH minus ions. So because of that, we've got an excess of both water and H plus. And we essentially use these when we're working with these half equations, excuse me. So, next step, balance the O's with H2O. We're able to do that because we've got that excess of water. So we've got 5 H2O on the right, 2, 4 on the left. So we need one lot of H2O to balance that out. Next, balance the H's with H plus. So here you can see we've got 2 H on the left, none on the right, so we're going to add 2 H plus to balance the hydrogens. And last thing, we need to balance the charges. So on the left hand side we've got a total charge of 0. On the right hand side we've got a total charge of 2 plus. So to balance those charges we need to add 2E minus, so that now we've got a total charge of 0 on both sides. Now, last thing, check the oxidation numbers work in terms of the electrons. So on the right-hand side, oxygen's in group 6, so it's got a 2 minus oxidation state. We've got 2 of those. We know everything's going to equal 0 because we've got no charge on the outside. We've only got 1 here. So the vanadium must be 4 plus. On the right hand side, we've got 5 lots of the 2 minus. We've got no charge on the right, so everything has to equal 0 here. This time we have 2 lots of vanadium. So we get to 10 minus here, divide that 10 by 2, we must have an oxidation number of 5 plus for each of the vanadium. And that makes sense. We've got each vanadium losing an electron to become 5 plus. Because remember, we've got 2 of each of those. That works perfectly. Next. Let's move our rules under. Let's make sure we're following these rules each time. So, first of all, balance the atom that's changing first. So that's anything other than oxygen or hydrogen. Hopefully you're thinking about what that's going to look like. Yeah, we've got 2 Fe on the right, 1 on the left, so we need 2 here. Balance the O's with H2O. We've got 3 on the right, so we need 3 H2O. Balance the H's with H plus. We've got 6 on the left, so 6 H plus. And finally we balance the charges. Got no charge on the left. We've got 6 plus on the right, so we need 6 electrons to make sure they're the same. Check that works. Iron is 0 here because it's in its elemental state. Iron on the right hand side, we've got 3 lots of these 2 minus, 2 lots of iron, that's going to equal 0. So here the iron must be 3 plus. Each of these ions, losing 3 electrons. That makes perfect sense because you've got 2 of them. Last one. So, this time we've got chlorine. Balance the atom that's changing first. So here, 2. Next, balance the oxygens. We've got 6 on the right. Don't make the mistake of forgetting the 2 here. Balance the hydrogens. Balance the charges. No charge on the left. On the right, we've got 2 minus, 12 plus, that's 10 minus, 10 plus in total. We need 10 electrons to balance that out. Let's check that makes sense. Chlorine's an element here, so it's 0. And on the right hand side, we've got 2 lots of that sorry, 3 lots of the minus 2. All equals minus 1. So each of those chlorines must be 5 plus. We've got 2 chlorines, so this 10E minus makes perfect sense. We're golden. So, next thing to do is for you to do the same thing using these rules for these examples here. I'll answer that at the end of next video. For now, let's have a look at how we did here. So, again, oxygen is pretty reliable. So we can really think about that. We've got 2 lots of minus 2. The whole thing equals 0. So nitrogen here is going to be plus 4, oxygen minus 2. Oxygen is going to be more electronegative, so we know it's going to be the negative one. Next, this time we've got 3 lots of the minus 2. The whole thing's going to be equal to minus 1 because we've got the charge here. Therefore, x must be plus 5. This one, nitrogen element by itself, so it's 0. KCl. Cl's in group 1, Cl's in group 1, so it's minus 1. Cl group 7, so minus 1. Potassium group 1 plus 1. Makes sense. Next, common ion, sulfates. We've got 4 lots of the 2 minus from oxygen. Whole thing is going to equal minus 2 because of our charge on the outside. Get to 6 plus. Bit harder. Sodium in group 1, so we can assume it's plus 1. Got 2 lots of those though, 2 lots of plus 1, plus 3 lots of minus 2. Whole thing's going to equal 0. What's carbon there? Plus 4. Again, all makes sense. Carbon's always going to be plus 4, minus 4, generally speaking. Last couple. Chromium's group in D block, so it could be anything really. Got 3 lots of this minus 2 from oxygen. Don't know what chromium is yet. The whole thing equals 0. We've got 2 lots of chromium. So here chromium must be plus 3, sorry. Here, 3 lots of this -2 equals 0. Only 1 lot of chromium this time. Here it's +6. Last one, whole thing equals -2. We've got 4 lots of -2 from oxygen. That means manganese must be +6. Hope that makes sense. Hope you've got them all right. Next time we'll look at combining half equations. Until then, happy revising.